This is a solution to learning assessment E9.5. Says find ZL for maximum power transfer and the maximum average power transferred to the load. We're going to be utilizing two problem solving strategies. One is maximum average power transfer and the other one is applying Thevenin's theorem. And if we look at the strategy on maximum average power transfer, first step says remove the load ZL and find a Thevenin equivalent for the remainder of the circuit. So if we look, then we want to find the Thevenin equivalent for this part of the circuit. So that's step one, is to find the Thevenin equivalent. So we're going to remove ZL and we're going to find the open circuit voltage and the Thevenin impedance for this circuit, and we don't have any dependent sources, so our first step then is to remove ZL and find the open circuit voltage. So here's our circuit. We've removed ZL. Here's our voltage, VOC, that we need to calculate. And if we look, we really have a single loop circuit here. Let's define a current I1, and let's calculate I1. Once we have I1, then we can apply KVL around this loop to find VOC. So if we apply KVL to this circuit, starting here and going around clockwise, we'll have minus 12 at an angle of 0 plus J2 times I1 plus 2 times I1 minus 24 at an angle of 0. So we have 2 plus J2 times I1 is equal to 36 at an angle of 0. Or that I1 then is 36 at an angle of 0 divided by 2 plus J2, which is 9 minus J9 amps. Now we're going to apply KVL around this loop to find VOC, and if we do that, we get VOC is minus 12 at an angle of 0 plus J2 times 9 minus J9. Now, there's no voltage across this element because the current flowing through it is 0. Okay, so the open circuit voltage then is 18.97 at an angle of 71.57 degrees. So there completes our calculation of the open circuit voltage. Now to continue on with calculating the Thevenin equivalent, we need to now find Z Thevenin. So we're going to take this circuit and we're going to take these sources and set them to 0. So we're going to place this with a short and this with a short. The resulting circuit is this, and now we need to calculate Z Thevenin. Okay, and Z Thevenin is the impedance looking into this port. So for Z Thevenin, we can just do impedance and admittance combinations. We have these two in parallel, so if I look at the admittances and take the reciprocal, I'll have 1 over 1/2 plus 1 over J2 plus a minus J2. So that gives us that Z Thevenin is 1 minus J1. Now, in our problem solving strategy for maximum average power transfer, the second step is to draw the Thevenin equivalent circuit and hook our load ZL back up. So Z Thevenin is 1 minus J1. So here's our Thevenin equivalent circuit. The open circuit voltage is 18.97 at an angle of 71.57. Now we're going to hook up ZL. Okay, so that completes step 2. Now step 3 says select ZL equal Z Thevenin conjugate, which means we have 1 minus J1 conjugate, which is 1 plus J1. Now our current IL, let's calculate it. So IL is 18.97 at an angle of 71.57. 1 minus J1 plus 1 plus J1, which is 9.485 at an angle of 71.57. So the load power then is 1/2 9.485 squared times 1, which is 45 watts.